everyone. In this video, we will be seeing multi-video streaming and object detection project. So, in this, we will be integrating Kafka, Torchserve, Flask, Docker Compose, MongoDB, and it will be deployed in AWS EC2. We have the Confluent Kafka is a different version of it's a different. It was developed by the Kafka founders only, but it's like a different part of Kafka, which inherits Kafka. So this is what we'll be seeing in today's video. Thank you. So now let's get inside the project. First, we can create a GitHub repository. Let's have a README, then Python git ignore, and then a license. Let's clone it. So first, let's create a template for the project. So in the template, we'll be adding the files that we are going to create in the project. These files will be created by the template so that uh, like uh, there is no need of manually creating each and every folder and file. Uh, it saves some time for us. So we are adding logging everywhere. Logger should be added, and then so the project name we are going to keep is object detection. The list of files, these are the list of files that we are going to create. This part is used for data ingestion to prediction stage, and then config.oaml contains the paths or the file names that are going to be that is going to be used by the configuration. And then DVC is the version control pipeline that we are going to use. Params.oaml, it contains hyperparameters that we are going to use, requirements.txt packages that we are going to install, setup.py. It enables us to create a library kind of environment so that it gives us a setup for the project. Then this research folder, this is the place first where we'll be playing with uh, notebooks. So we'll be creating raw notebooks. From that, we'll be transferring to the files. Then templates.index.html. So this will be coming under consumer. So I'll delete it. Torchserve is used to serve the torch model. Oh, sorry, PyTorch model. But we are going to use ONX here. And then this part of code. So this part of code is used for creating the directories and everything. So let's create a code environment. let's activate the environment. So now let's run the templates.py file. So in one with one command, we are able to create this much files. So it saves some time for us. Then now let's fill the requirements.txt file. So basically, we are going to use YOLO V8 model. So that's why we are installing Analytics. Then Torch is for Torchserve, and then DVC is for uh, data version control. Then we can remove MATLAB and C bond, and then we are going to use Flask. Flask is our framework for application deployment. Then ONX is for ONX model, that is we are going to deploy with Torchserve, and then Confluent Kafka, that is the Kafka framework which you are going to use. Kafka and Confluent Kafka are more or less similar only. Confluent Kafka is add some additional features. And then Flash socket.io. So this is used to transfer the video, the image frames to UI. And then PyMongo is MongoDB framework for integration with Python. So now let's run Python R, sorry, pip install R records. Okay, I created this environment already, so with this in name, or maybe it's the problem. I'll create another one environment. So I found that we didn't fill the setup.py file, so I'll fill the setup.py file first. So first we are reading the description from README and then setting the version. Then we are giving the repo name. So our repo name is I'll go to here multi-video object detection MLOPS project. That is our repo name. You can give your username or GitHub username and then source repo name. This one you can give anything. SRC repo name and then author email. So you can give your own. Then this is setup tool start setup. So this, yeah. So now I think now it should work. Yeah, it's working. Okay, it has installed. So this is the source folder, and then now let's create notebooks so that we will come to know better how the um how the data set is. and then how to take the data set, create a data ingestion pipeline, and then prepare a base model, training, and then evaluation pipeline. So yeah, we can do this in a single script also, but when we do this in these many stages, it will act as a template for other. It will act as a template for act as a template even when you create other projects. So that's why we are going in this method. Yeah. So this is the data set that we are going to use in this project. Um, so I have already uh, took the data set, and then I have okay, let's download it. Okay, we have to download the data set. So in this data set, I have took some few images and created a train and test folder. So with that train test and validation folder, so with that time we can proceed because I have only a CPU. So with CPU, if I if I unzip and zip uh, and then train even for one epoch all these 4000 images, 4000 to 6000 images in this data set is going to take a long time. So I've already splitted the train test and validation data set, and then I have kept it. So I'll show that folder. So this is the folder dataset.zip. So datasets or does it in this folder I have extracted some images, so I'll show you. So it's not opening there. Maybe I'll open it somewhere. So there were around 6000 images. I have extracted for a few of them alone. So these are the images. So already argumentations are done. Some of the argumentations are done, I think. So mostly it has 5 classes. Uh, the classes were, I think, these are the yeah, these were the classes: person, car, bicycle, bus, and motorbike. So five classes. There were totally 6,633 images, but I have reduced it because we want to train it in CPU, and then they have applied these data augmentations already to the images. Yeah, so let's go and start using the data set. So let's put it into a folder first, data folder. Let's move the dataset.zip into dataset.zip into data folder. So now let's push it to the GitHub because we wanted to use this in our data ingestion pipeline. So that's why we can push it to the GitHub. We can push everything, I think. Whatever we have done till now, we can push everything to GitHub. Then we have to add PyCatchy to gitignore. Okay, it's already added. Yeah, now we have pushed it. So what we are going to do now is we are going to take a URL. So this is the URL we are going to copy. So this URL we need. So let's write the config file. So in config file first is data ingestion. So in data ingestion part, we are going to add first the root directory, and then source URL. So the source URL for data ingestion is this. That is what we took now. And then where it is to be stored locally, and then where it is to be unzipped. So these are the places it should be. We are planning to store it in data artifacts, data ingestion, dataset.zip, and unzip.dar, unzipping it inside data ingestion. So now let's try it. Let's jump into the code. So first let's create data ingestion. IPYNB. So in data ingestion, like first we can change the directory. Okay. So first we can create the entity data class. Uh, so we need uh, we need the root directory, then source URL, local data file, and unzip directory. Whatever you mentioned config is coming here, and then we can run this. So here we are importing the constants and common util files next. So before importing it, we have to complete the constants and then complete reading the constants, and we have to fill the utils file. So constants. Okay. So yeah, we are reading both config and params.yaml file in constants, and then utils file. So these are common utilities that we'll be using: reading OAML, and then creating directories, saving JSON, and then updating dataset directory in Python and in Linux and Windows, like that. So after this, let's run this now. Okay, we have to write logger also. So logger can be written here. We are creating the logging directory, logs, a log file, running logs.log. Then yeah, we are creating with the name object detection logger. So now we have to restart. Yeah, it's imported. Now configuration manager. So let's create a configuration manager. So in this configuration manager, initially it will try to create the directories from the directories by reading the YAML file, and then and then this is the data. This config is will be specific to data ingestion. This will be common to everything while converting into a file. So here we are creating a data ingestion config class, and then reading the config reading the config files, and then creating a tip kind of object, and then we are creating data ingestion class. So in this data ingestion class, initially we are reading the config. So after reading the config, we are downloading the file, that is the zip file which is there in GitHub. So that will be downloaded. So after it's being downloaded, we will extract the zip file. So extraction function is written for that. So yeah, then we are now we can now execute whatever we created in this notebook. Okay, we didn't run a notebook. Okay, you have to fill the YAML file also. Params.yml. These are the hyperparameters which we are setting: image size, batch size, then classes, then weights, default weights, learning rate, and then whether to include the top alone is false. And then epochs you can raise to whatever limit you want. Since I'm running it in a CPU, I kept it as 1. If you want, you can keep it as 60. 60 is the epochs rate at which you can get the good model for this data set and model. And then yeah. So if you see the artifacts now, dataset zip is cloned from GitHub, sorry, copied from GitHub, and then downloaded from GitHub, and then it's being unzipped. So now let's transfer this code to files. So yeah, so now we can transfer the codes to files. Initially, we created the entity, so we can start from there. And then configuration. So let's go to configuration. Then we have created the data ingestion. This would come under components. I think there are no errors now. And then and then this will come at a pipeline. Let's create a main file. So we are doing this because to ensure that DBC pipeline runs properly. So that's why we are creating this pipeline. So what happens is when DBC in when you are calling the DBC repro rules, it is called DBC means data version control. So when you are calling the DBC repro, each of these files like stage 1 file will get executed, stage 2 file will get executed. So that's why we are creating this main function. So when you call this main object, it will execute this main function. So this main function is this will get executed in components, taking information on components configuration and entity, and then processing it, and then it will be coming here. So after this, let's go to next stage. So okay, before going to next stage, let's test it with in main.py whether it's working or not. What we have done. Let's give a stage name, data ingestion stage. Then let's try to run it. It seems that even if you clear it and if you run, it will download it from first. Since it's already present, the data set folder is already present. It is not downloading this time. So yeah, so that's why.